All right, y'all. Time for another video. This is on like a extra problems for chapter 11, a worksheet for chapter 11 here. This is the key. Let's see if I can do these problems. Why not? Find the Taylor polynomials P1, P2, P3, and P4 for the function f of x equals 2 cosine negative 6x centered at a equals 0. So this is the equation for a Taylor polynomial right here, right? If I plug in a 1 for n, that means I go from 0 to 1, which means the first two terms. I plug in a 3 for n, and I'm looking at the first from 0 to 3, so 4 terms. So what do we need to do? We need to find essentially just what this term is for all of them, right? So I need f of a equals 0 here, right? So let's find f of 0. Cosine of 0, cosine of 0 is 1. So I'm going to have 2 here. F prime of 0 will be, actually, we need to find these derivatives first, right? F prime of x. Let's do this. Let's do this way. F prime of x is equal to what? Negative or positive 12 cosine, excuse me, goodness, sine of negative 6x, right? Because this derivative is 2 times negative sine of negative 6x times negative 6, so that is positive 12. Yep. But f prime of 0 equals 0. Double prime of x is equal to negative 72 cosine of negative 6x. That negative comes from this, the chain rule, not from the derivative of sine, right? F triple prime of x is equal to, oh my gosh, why did I give this problem? What is this? 452, I think. So negative 452 sine of negative 6x. I'm gonna just check this. I'm gonna check that one. Give me a second. Give me a second, yo. Negative 452. Oopsies. Let's go. Let's. I can't use my calculator, can I? 72 times 6. Negative 432. Golly, golly, golly. You guys deserve better. And it stays negative because chain rule will give me a negative, but the derivative of cosine is a negative. So negative times a negative is a positive, and it was negative to begin with. So negative, negative, negative becomes negative. And lastly, the fourth prime here. So one more derivative, we're going to have a negative again. So what is 6 times? 6 times 432. 2,592 cosine of negative 6x, like that. All right, what is the double prime at 0? So plugging in 0 here, I get negative 72. What is the triple prime at 0? I get what? 0, because sine of 0 is 0. And what is the fourth prime at 0? That is 2,592, like that. So these are my f of a's, my f prime, f double prime, f triple prime of a's. So we can do that to find all these p's. P1 of x is going from 0 to 1, right? So I'm going to have the first term, which is f of 0. I'll write this one out, actually. So f of 0 over 0 factorial x minus 0 to the 0 plus f prime of 0 over 1 factorial x minus 0 to the 1, right? So you can plug in these numbers. I know f of 0 is 2, 0 factorial, add to the 0 power, so it's 2 plus the derivative is 0, so it's just 2 for this one. P2 of x is going from 0 to 2 now, right? So I'm going to write the first two terms, which those first two terms is 2, plus the last term, plugging in 2. So I'm going to have negative 72 over 2 factorial, x minus, or just x, which is 0. X minus 0 is x to the 2 power. Okay. P3 is equal to the same stuff, plus negative 72 over 2 factorial x squared times the third term. So when I plug in the third derivative here, right, the third derivative is 0. So it's going to be the same thing. It'll be plus a 0, right, when I do 0 times this stuff. And then I'll do P4, which is P3, 2 plus negatives. I'll simplify this. This is negative 36 x squared plus, and then we have 2592 over 4 factorial x to the fourth. Nice. All of our answers set at 0. Okay. Using the table of Maclaurin series, find the Maclaurin series of f of x by comparing to the Maclaurin series for cosine of x. For that, we need to find our Maclaurin series. This is the Maclaurin series right here, right? This list I gave in class or the list I gave in my video notes, right? So let's plug that in. -1, so what's cosine of x? Cosine of x is the summation from k equals 0 to infinity of -1 to the k cosine, oh, that's cosine, x to the k, 2k over 2k factorial. Is that what I got here? Nah, that's the wrong one. Actually, 2k over 2k factorial, that looks good. Okay. So if that is what cosine of x is, what is cosine? Or 2 cosine of -6x, right? Okay, 2 cosine of -6x is plugging in. If I have x here and x there, like I'm composing with -6x now, so my -6x should be a summation from k equals 0 to infinity of -1 to the k, -6x to the 2k over 2k factorial. Well, that is what that does, but I have 2 times that series, so I could just multiply by a 2 here, right? I can get, if I ignore this part, right, I can get this by just replacing with -6x. I can get double this by doubling that series, right? You can distribute it as well. You can put the 2 on the inside here. But yeah, I'm fine leaving it like this. And maybe you can. If you leave it there, that's fine. I'm gonna put the 2 inside here as well. Because right, this is a series, so you can just distribute that term to everything. Yeah, so this is all the answers looking for here. So I'm just gonna leave it like that. Use your answers for P1, P2, P3, and P4 to approximate f of x at x equals 1, then compute f of -1, f of 0.1 in the calculator. So what is P1 of 0.1? Well, that's just plugging it into here. Oh, that's just 2. What is P2 of 0.1? That is 2 plus -72 over, over 2 factorial, or 2 factorial times 0.1 squared. So now we got to get a calculator, right? Let me get this calculator out. Where are we? Okay, so 2 minus 72 factorial, or 72 divided by 2 is 36 times 0.1 squared. That is equal to 1.64. P3.1 equals the same values. So 1.64 P4 of 0.1 is equal to this same stuff plus this next term. So I'm just going to write 1.64 plus 292 over 4 factorial 0.1 to the fourth. 0.1 to the fourth. So let's do the same answer plus 2592 divided by, 4 factorial. That's 12, 24. 24 times 0.1 to the fourth. So this is 1.6508. Okay, so what is f of 0.1, which is 2 cosine of -6 times 0.1. So 2 cosine -6 times 0.1. Oh, yikes. I need to change this. I need to change this, don't I? How do I do this? Um, do I go to mode? Radian. That's what I want. I want radian. Why am I in degrees? Radians are always way better. So let's go back. Enter clear. So now let's go back up. Answer. There we go. That looks better. 1.650 671. Why not? And notice, that looks pretty darn close. I'm not going to find the absolute error or anything, but 1.6508 versus 0.7, very good approximation we have here, right? Okay. I don't know if I need this anymore. Let's move that out. Okay. Recall we often use ratio tests to find the interval of convergence. Find the interval of convergence of this. Well, ratio test. How do we do ratio tests? We do the limit. It's k approaches infinity. The absolute value, 3x minus 5, or I'll write it out first. AK plus 1 over AK, which is the limit. It's k approaches infinity of 3x minus 5 to the k plus 1 over k plus 1 to the fourth plus 4 times k to the fourth plus 4 over 3x plus 5 minus 5 to the k plus 1. Or just the k, excuse me. Okay, that should be able to cancel. In particular, I see that this k cancels with this, so I'm just left with 3x plus 5 on the top. And I can move that out, or move everything else out of the absolute values here. So I'm going to do that all in one step. This is, I have an absolute value, 3x minus 5. Everything else, k to the fourth plus 4 over k plus 1 to the fourth plus 4. And okay, there's lots of, here, let me move this over here like that. I think this will be easier. There's lots of ways we can simplify this, right? If we did FOIL all this out, we would have a k to the fourth in the denominator. We leave this as is, we have k to the fourth in the numerator. So the leading terms are k to the fourths. So let's multiply by that. 1 over k to the fourth, that's 1 over k to the fourth. What do I get here? I get the limit, k approaches infinity, of 1 plus 4 over k to the fourth in the numerator. In the denominator, I'm going to have k plus 1 to the fourth over k to the fourth plus 4 over k to the fourth. Oh, and I still have that 3x minus 5. Well, this is k plus 1 over k to the fourth, which is 1 plus 1 over k to the fourth, right? So this goes to 0. This is going to be 1. This goes to 0. This goes to 0. So I have 1 over 1. So this just equals 1 times 3x minus 5. That needs to be, let's kind of underline, let's do this in orange here, or let's highlight this. This needs to be less than 1 in order to converge. So this is what we have here. So how do we find the radius of convergence? You need it to be of the form x minus a is less than r. That's how you find your radius. So I'm going to divide everything by 3 or factor out a 3 here. So we have 3 times x minus 5 over 3 is less than 1, or x minus 5 over 3 is less than 1/3. This is the radius here. So we have radius convergence of 1/3 here. Find the interval of convergence as well. So that's not that bad. We just start with this, less than 1/3. Then we split the fraction, or not split it. We change it to a positive and negative version. That's how you do this stuff. And if we add 5/3 of everything, we're going to have 6 over 3 and 4 over 3. Or 4 over 3 is less than x, which is less than 2 here. Hopefully I got that right. Let's see by plugging in endpoints. So endpoints. So actually, let me not, that's not our answer yet. What's the endpoints here? So at x equals 4 over 3, we have the summation k equals 1 to infinity of, well, when I plug in 4, let me just write it all out. 3 times 4 over 3 minus 5 to the k over k to the 4th plus 4. So this simplifies to being 4 minus 5, so negative 1 to the k. K equals 1 to infinity of negative 1 to the k over k plus to the 4th plus 4. So we can see here, if you use the alternating series test, we don't have to do it all. I can say decreasing and the limit as k approaches infinity of 1 over k squared plus 4 equals 0. This converges by alternating series tests. So it's helpful to be good with our tests, right? At x equals 2, we're going to have the summation from k equals, this is supposed to be from, is it from 1 or, oh, it is from 1, okay. From k equals 1 to infinity of 3 times 2 minus 5 to the k over k to the 4th plus 4. That is equal to the summation from k equals 1 to infinity of 1 to the k, so just 1 over k to the 4th plus 4. Yeah. If we compare to 1 over k squared, 1 over k squared plus 4 is less than 1 over k squared, converges by p-series, so converges too. Final answer is what? What's the final answer? They both converge, so our interval is going to have both those values. 4 over 3 to 2. Now, I didn't like go like super into showing converges and stuff like that. Really, it's just like, oh, this looks like a p-series, and p-series per k equals 4, k to the 4th power, that converges. This is an alternating series thing, but if the absolute thing converges, then this converges as well. So it's not too bad, right? But really, we did 2 tests there, and citing your tests are good. All right, last few problems here. Use a table given in class, find the series representations for the following functions. So let's find what sine of x is. The sine of x was this one. Negative 1 to the k, 2k plus 1, 2k plus 1 factorial. Series from k equals 0 to, or k, yeah, 0 to infinity, negative 1 to the k, x to 2k plus 1 over 2k plus 1 factorial. Now, I'm not going to write down the first four non-zero terms. Maybe I will. Never mind. So sine of 6x to the ninth is just replacing this with 6x to the ninth. So k equals 0 to infinity, -1 to the k, 6x to the ninth to k plus 1 over 2k plus 1 factorial. Now, you don't have to go and simplify this more, right? It's totally okay to just leave it like that because that's a series representation. Maybe it doesn't look that ugly, that nice. Maybe you can split this to be 6 to the 2k plus 1 and like work from there or something. Why do that? Let's just write the first four terms. So we have k equals 1, or k equals 0, that becomes positive. So this is 6x to the ninth over plugging in 0, 1 factorial, so 6x to the ninth. Plus, now we're plugging k equals 1, -1, 6x to the ninth to the 3 power over 3 factorial, plus 6x to the ninth to the 5 power over 5 factorial, minus 6x to the ninth to the 7 power over 7 factorial. Those are the first four non-zero terms here. And that's why I like writing it just how it is, right? I'm replacing x with x to the 6x to the ninth. When I plug in k equals 0, these all add up. When I plug in k equals 1, 1. This is 2 times 1, so 3. 3 factorial. That's exactly what this is. Negative this to 3 power over 3 factorial. And notice, that looks just like this. It's like, imagine if I replace this with 6x to the ninth here. 6x to the ninth, 6x to the ninth, 6x to the ninth. I have 6x to the ninth minus 6x to the ninth cubed plus 6x to the ninth to the fifth. Ooh, 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 yes, right? All right, let's do the same for sinh. 6x to the ninth equal to the series representation is just x to the 2k plus 1 over 2k plus 1 factorial. Equals 0 to infinity, x to the 2k plus 1 over 2k plus 1 factorial. So, oh, this is sinh of x, excuse me. So sinh of 6x to the ninth equal to plug and chug, right? There's no calculus here. You should be enjoying these problems, right? 6x to the ninth, the 2k plus 1 over 2k plus 1 factorial. What does that equal to? Plugging in 0 power, we have 6x to the ninth. Plugging in the cubed power, we have 6x to the ninth cubed over 3 factorial. And then the fifth power, the fifth 5 factorial, and the seventh power, 7 over 7 factorial. Let me move this over. Cool. Plus dot dot dot, plus dot dot dot, right? Those are the first four non-zero terms. Okay. Wait a sec. Is this not working? Okay. I don't know what's going on. I can't move my this page for some reason, but that's fine. Identify the function represented by the following power series using the given table in the class. So we have this. I have, oh, I'm gonna make this equal to, I see something here. 0 to infinity, I have -1 to the k. I'm gonna make this all x minus 2 over 8 to the k power. Does that look like any of the series we know? Well, this one, right? I have -1 to the k, something to the k power. So if I replace that something with x here, or if I place that x with that something, I get my exact formula. So this is equal to 1 plus x minus 2 over 8. And if I multiply top and bottom by 8, I get 8 over 8 plus x minus 2, or what? I get 8 over 6 plus x. You don't need to do that, but that's what we have either way. Why is this happening? For some reason, I can't move my value here. That's totally fine. Okay, I'm going to move this to be the summation from k equals 1 to infinity of x to the 11th to the k power over k. Is there something that just has divided by k in my table here? Well, let's look. I see a k here, but this has a negative k plus 1. Here we go. This is just x to the k over k. So I replace that with x to the 11th, I get my exact problem here. So this is, wait, what was it? It was negative ln of, so this is equal to negative ln of 1 minus x to the 11th. Bing bada boom. What's it absolute valued? It probably should be absolute valued. It's not though. So we have a radius of convergence problem here, but that's fine. Yeah, you need that for radius of convergence. Okay. So we identified the functions and we are good. This is not showing on the screen. This is 6 plus x on the denominator there. And there we go. Thanks for watching.